at InModge, and the theme for today's webinar is going to be how you can leverage our product to back up and replicate any type of Windows servers, whether it's physical or virtual, into a VMware target. We have muted everyone on this webinar. If you have any questions during the course of this presentation, please type it out in the chat pane and we'll get to it at the end. The webinar is going to last approximately 30 minutes and we are recording it, so you will receive a link to this webinar in a couple of days. So to provide a high-level introduction, InModge has a single product that can basically perform local backup and remote replication for Windows servers into a VMware target. The primary systems can either be physical or virtual. We're completely agnostic to that. And if they're virtual, they can run on any type of hypervisor, so they can run on either VMware or Xen server or Hyper-V at the primary site. The protection approach is very much full system, so we're not only replicating or backing up your data, but we're also backing up the OS volumes and the application binaries and configurations along with it. The product automatically handles P2V and V2V conversion as part of the deployment process from any hypervisor into VMware. The architecture is based on continuous data protection. So what this means is we are tracking and replicating deltas or data changes continuously 24/7. And we journal them at the target site, so that way you can roll back and restore your virtual machines or data to any point in time. So it's a really optimal architecture in terms of the best possible RPO and RTO as well. In terms of the impact that it causes at on the production servers, it's extremely minimal because we are able to track and replicate or backup changes directly from the memory of the production systems. So it fits right into existing environments. The tracking and replication or backup of the changes happens through an extremely lightweight data tab on the production systems. And it is extremely low impact, as I mentioned, so it can function in environments with extremely high workloads. In addition, the product also comes with built-in techniques to reduce the amount of data we transfer over network, especially for the replication case to a second data center across a WAN link. We also have built-in techniques to optimize how much target storage we consume on the target site, whether it's for backup or DR purposes. So here's what a typical architecture looks like when the product has been deployed for both local backup as well as remote replication or disaster recovery. On the top left-hand side, we have the production virtual machines and physical servers. As I mentioned before, the VMs can run on any hypervisor. We support VMs running on VMware, Xen server, or Hyper-V. And there's a lightweight software component identified by this triangle that gets installed on all production systems that need to be replicated. The data tab that is installed does not require a reboot of any sort, so there's no maintenance window needed to install it. It's got an extremely small footprint in terms of both CPU and memory consumption, and in normal operation there's absolutely no I/O performance impact because of the operations that the agent is doing. In terms of the actual operations, the agent basically tracks data changes directly from memory of the production virtual machines or physical servers and ships it off to this appliance. The InModge appliance is software only, so it can run on a standard 1U or 2U server, or it can be a virtual appliance as well. And it undertakes the responsibility of caching all the data changes, compressing it, and optimizing it for replication across the WAN. So if you look at it, it's a host offload architecture, and all the heavy lifting is really performed by this component. On the target side, we have a VMware infrastructure. Basically, you have the servers on which VMware is installed. We support versions 3.5 to 5.0. And there's storage, of course, that has been presented to VMware as data stores. And we have this one virtual machine that we call the in-match target that's running on that infrastructure. This target is responsible for updating the copies of the replica virtual machines, or shadows as we call them. These are essentially the counterparts of the primary servers that you're backing up or protecting. And the target is also responsible for maintaining the change journals that allow you to recover these shadows to different points in time if you wanted to recover from logical corruptions, for instance. Now the same stream of data that is sent to the appliance at the primary site can be split two ways. One can be sent locally for local backup purposes, and one can be sent to the remote site for DR purposes. The actual shadows or replicas, as I mentioned, are automatically provisioned by the InMatch product. So you don't have to create these virtual machines on the target side. You can, as part of protection policy, you can also specify the size of these virtual machines, these shadows or standbys that are created, so you can customize the number of CPUs, the amount of memory, and you can also specify the network settings that they need to assume upon recovery at the second site. There is a standby appliance at the second site as well for the remote case. And the purpose of this appliance is to perform UI-based recoveries in the event that the whole primary site was lost in a natural disaster. So let's take a look at the high-level features when we talk about the backup capabilities of the InMatch product when you're backing up to VMware. So on the primary side, we don't take a CBT, a change block tracking based approach. We are siphoning off the data changes or tracking the data changes and replicating it directly from the memory of the production servers. So what this means is there's absolutely no disk I/O impact on the production systems because it's not a CBT based approach. And because it's happening continuously 24/7, what this essentially means is that there are no backup windows, absolutely. The changes are replicated in a small trickle as opposed to a traditional approach where there's a backup window after production hours, after business hours, and for the duration of that window there's a significant I/O hit. There's deep application consistency enforced on the production systems through VSS integration. So for instance, if there's Exchange or file servers or SQL that's running on the production systems, we would talk to the corresponding VSS writers of those applications and quiet them and enforce that everything that we're replicating at that point is consistent. Another thing to note is that the quiescing with our approach takes just a few seconds as opposed to the complete duration of the backup window with the more traditional approach. In addition, because of this consistency enforcement, we can offer recovery on the target side to consistent points. In addition, we can also recover your data to any right-ordered crash consistent point as well because we are CDP based and we are replicating changes 24/7. Sorry, give me 1 second. Okay. We leverage a technology on the target side called virtual snapshots. Basically, virtual snapshots allow us to present a virtual view of the data for recovery, and this does not consume any additional target storage. So it's pretty optimal for recovering just the data. We have a number of techniques to optimize the consumption of target storage. One of them is sparse retention. Basically, as I mentioned before, we maintain a journal of all changes that we are backing up or replicating for, say, the last 7 days or 30 days or the last 6 months. And there's a feature called sparse retention that basically maintains less and less frequent recovery points as time progresses. So this provides significant savings in the target storage utilization that can achieve dedupe type efficiencies. The actual journals are compressed for additional capacity savings. And also, even when we do the initial sync or the mirroring, it is file system aware. So the data that we're backing up, even though it's at block level, it is aware of only the file system use portion. And of course, the virtual machines on the target side are always thin provisioned. So that further provides some capacity savings on the target side. So these are basically the replication features that we can do when backing up or replicating to VMware. So looking at replication specifically, InMarch includes the replication engine as well as the failover management framework within one product. So what this means is you don't need array-based replication or SRM licenses because we provide the equivalent of both of those in one product. At the same time, our protection policies are not defined at the LUN level. You can pick and choose which VMs you want to replicate. So this gives you the flexibility of just replicating the critical VMs and excluding the non-critical ones that happen to be on the same LUN as the others. So this gives you not only ways to optimize the target storage and just pick and choose the ones you want to replicate, but it also gives you savings in terms of the network utilization because you're only replicating the critical ones. Further, we very much support replication between different kinds of storage, so we can go from any storage vendor and model to any storage vendor and model because we operate at the host level or the guest level in the virtual case. So we're not tied to a specific model of array on the source and the target, so it gives the customer the maximum flexibility in picking and choosing which storage vendor they want to go with. The same holds true for the storage technology as well. So at the primary side, you could be using Fiber Channel or iSCSI or DAS, and you could be using something completely different on the target side. Again, because we're CDP based, we always maintain the latest copy of the shadows on the target, which is ideal for the best possible recovery time objectives. Basically, we can approach sub 30-minute RTOs when we're talking about recovering 50 virtual machines. And of course, there's deployments that can be done in parallel to keep that RTO number down. The same holds true for RPO as well. Because we're based on CDP, you can recover virtual machines on the other side, on the target side, with basically near zero data loss. We do a lot of the last mile automation, such as adapting the virtual machines on the DR side to the networking scheme there. So it's not left to the administrator to perform those tasks after recovery. So we do a lot of the last mile orchestration and automation to minimize the overall RTO. And additionally, because we're talking about DR to a second site, we perform a lot of the network optimization like compression, WAN acceleration built into the product. And additionally, the appliance that is deployed at the primary site can also perform consolidated bandwidth management. So what this means is you can have a policy during business hours that says use only 50% of my available bandwidth for DR purposes, and after business hours use 90%. So on the right-hand side here, I have a screen that shows what the product looks like while deploying a protection policy. So for VMware, on the source and the target, we have full vCenter integration. So that greatly simplifies the actual protection and recovery operations while keeping things secure. So you can sign on with your vCenter credentials, and you don't need to provide the ESX host credentials while setting up protection and recovery policies. It also makes things easier. In one pass, you can protect basically all the virtual machines that are in the vCenter umbrella. So it lends itself to significantly faster deployments. And if it's virtual machines that run on other hypervisors or physical servers, then the tool automatically takes care of the P2V conversion or V2V conversion if you're trying to go from, say, Zen server to VMware. The tool also automatically provisions the shadow VMs on the target side. So that is some of the orchestration and automation that I was talking about previously. When the protection policies are first deployed, the product goes through a seeding process. This seeding is basically file system aware. Whether it's deployed for backup or replication or both, it is always file system aware. So if you have a 100 gig provision VM, but only 20 gigs is used from a file system perspective, then we'd be backing up or replicating just those 20 gigs. So it can lead up to 80% faster faster seeding times with this feature, and you can get similar reductions in the bandwidth usage and target capacity requirements. There's a number of features to improve the overall recovery time when we're talking about failovers. So anything that you need to customize as far as the shadow VMs go on the target side is done at protection time itself. So you can customize the number of virtual CPUs, the amount of memory, and the network settings that the shadow VMs need to assume upon failover. So all those things are specified during protection itself. Additionally, there's a lot of parallelization that goes on at recovery time to further improve the RTOs, and you'll typically see the larger the environment, the higher the RTO gain is. There's a lot of recovery sequencing that is performed by the product as well. So if you have a multi-tier application, you can bring up the different tiers of that app in the right sequence. So you can bring up the database tier first, followed by the middleware, and then the application tier. So you can do that through the screen that we show in this slide. Basically, it's a recovery order number that you specify for the right sequencing. In addition, we can recover all the systems of the multi-tier application to the same point, or we can recover them to a common application consistent point. There is a huge amount of rehearsal capabilities within the product as well. So you can perform DR tests by bringing up the virtual machines on the target side in an isolated VLAN, so thereby not affecting production in any way. There's two options when it comes to recovery. You can basically break replication and bring up the VMs as is, or you can choose to keep the replications intact and create snapshots of the virtual machines on the target side and recover the snapshots. So there's two options there, and both are non-disruptive to production. And all of these features that I'm discussing here is consistent across ESX or vSphere versions 3.5 to 5.0, and ESXi is included in that as well. Looking at the backup specific features, so the way sparse retention works, basically it's a target capacity optimization technique, and essentially a plain retention policy would look like retain every single change for the last 30 days. But sparse retention allows us to punch holes in that journal and say retain all changes for the last 3 days and 1 recovery point per hour for the next few days, and then daily recovery points beyond that. So this gives you a much deeper retention window on disk without consuming a ton of storage because of the nature of CDP. These recovery points that we maintain are always application consistent. So we are always aware of what application is running on the source, if it's Exchange, SQL, file server, Active Directory, and we'd be aware of that, and we'd make sure we'd maintain bookmarks consistent with respect to those applications. The other methods through which we minimize the target storage requirements is through thin provisioning the VMs on the target side, and also compressing the target repository in the backup case. So when we're talking about restores in the backup case, we have a technology called virtual snapshots that allow you to perform restores at any level. You can restore individual files or folders or complete disks. So all of these can be restored through our virtual snapshot technology, which does not consume any additional storage on the target site. Essentially, we're giving you a virtual view into the target repository that's maintained by the InModular target. We can additionally restore complete VMs as well, and that is through the physical snapshot approach. Further, we have extended support for Microsoft Exchange, so we can break open Exchange 2007 and 2010 DAG or non-DAG database files, and we can drill down into the mailbox and message level and perform restores directly to the home Exchange server. So what we've done is we've taken the all the capabilities that InModular has for being in being able to back up and replicate anything to VMware, and productized it as Scout Cloud. It's basically been adapted to protect customers' primary servers from their primary site into the cloud that's based on VMware. Again, it's one product for backup and disaster recovery as a service to VMware-based cloud providers. In addition, if a customer has primary servers that are already in the cloud, we can protect those too. So it's not necessary that the customer's primary servers have to be in their primary site. The product basically contains everything that a cloud provider would need in terms of ramping up their service quickly and going to market. So basically it's got a 6th generation replication engine based on CDP that basically replicates 24/7 and enables restores at any point in time. And it's got application consistency and all of those features. Scout Cloud also comes with a central portal that has multi-tenant support, and it's intended to be for central management by the operations team of the cloud provider, and also provide access to their partners and resellers and the end customers. So the multi-tenant capabilities allow more filtered read-only views within the portal for end customers, so they can look at the status of their server application and open support tickets and things like that. Scout Cloud automatically performs the V2V conversion for any Windows servers that are running on any hypervisor to VMware, and it also performs the P2V conversion automatically. So there's a significant amount of automation within the product to minimize the operational costs from a cloud provider's perspective. From an end customer's perspective, this is extremely attractive because they can sign up for a service like this and have a DR plan without the need for a second data center. So it gives a huge reduction in capital expenditure to the customer, because all the upfront costs of storage, servers, OS licenses, and the replication software are incurred by the service provider. And it's something there's basically a monthly fee per protected server to the end customer, and the cost for the infrastructure is it's got back over time by the cloud provider. The replica virtual machines in the cloud are very much dormant, so the customer only pays for compute and memory resources when they fail over. Another place where the end customer would get savings is they no longer need to maintain trained IT personnel for business continuity and DR operations, because all of that is managed by the service provider. On average, Scout Cloud deployments, because we are providing everything that you need in one product, these deployments complete within a month after the customer signs up. And there's, as I mentioned, there's a central portal that's available for the provider's operations team to monitor the status of replications 24/7. There's a significant amount of hooks to be able to send alerts and dispatch alerts via email and SNMP, so we can integrate our product with ticketing systems that receive alerts and issues via SNMP. And additionally, there's regular DR tests that are performed as part of the service. So again, these DR tests are performed with zero production impact, and that gives peace of mind to the customer that the DR plan that they have is valid and it works. So again, the approach that we take for replication to the cloud is very similar to the architecture slide that I went over previously. So on the left-hand side, we have the customer's primary servers, and there's a lightweight data tab that gets installed on each primary server. The data tab basically tracks changes and sends them to the appliance. In this case, we call it a cloud gateway. And the appliance takes on the responsibility of compression and WAN acceleration and caching and all of that stuff, consolidated bandwidth management. So it does all of that and sends it off to the cloud. In the cloud, we have the shadow instances that correspond to the physical and virtual servers on the source. The shadows are very much dormant. They're powered off, and they're only brought up when it's time to fail over and recover the systems in the cloud. We also maintain a journal of changes in the cloud that will allow you to recover these VMs to different points in time. Say there was a logical corruption a few days back and you want to go back to before that, you can do that with this. Again, the approach here is very much full system protection. So we're backing up and recovering the entire system in the cloud. And as part of that, we customize the virtual machines in the cloud and we adapt them to the networking scheme in the cloud. So we do all of that automation that is needed. So here's a reference architecture of what the deployment looks like from a cloud provider's perspective for multiple customers. So on the left-hand side, we have three different customers. Customer 1 is a mid-sized virtual environment. Customer 2 has a mix of virtual and physical servers, and customer 3 has a small virtual environment that's low change rate. So on the right-hand side, the cloud provider would basically share the back-end infrastructure in terms of compute, memory, essentially the servers and storage, and create silos for each customer. So the provider would carve out resource pools, and in each resource pool there's a dedicated in-march appliance and an in-march target to manage the replication for each customer. And each of these appliances that these three customers have would feed data to the central portal. So that way the operations team can use this as the launch point for all their centralized monitoring and other activities. One thing I do want to point out is that the appliance on the customer premise, which does the caching and compression, it is not mandatory. For small customers that don't have a lot of change rate, they can do source-based compression and replicate directly to the cloud without an appliance. And as always, the appliance itself can be, it's a software-only appliance, so it can function on a standard 1U or 2U server, or it can be a virtual machine. This is what the central dashboard looks like. The view that you see here is that of a super administrator. Basically, you have full privileges to monitor and change settings and action on those alerts. So basically, the super admin would see all the customers on the dashboard, and per customer, they could expand and look at the status of the individual servers that are being replicated. They are color-coded for easily identifying which server needs to be looked into. Green is good, red is bad. On the right-hand side, when you select a server, there's more detailed statistics that we show, like the recovery window, the current RPO, and the change rates for that server, both compressed and uncompressed. And there's additional tabs here that allow you to create accounts for end customers and your partners. And the alerts tab allow you to look at alerts that were generated across all customers. And of course, the end customer, when they log in to their account, they'd only see their servers in a more filtered view. And this UI can be completely rebranded to present your company's logos and things like that. So to summarize, what InMarch can do for VMware is basically back up and replicate any type of Windows servers. So it can be physical or virtual Windows servers running on any hypervisor. They can be backed up and replicated to a VMware target. So it's one single product for both backup and replication. The actual target can either be a private data center for end customers, or it can be a VMware-based cloud. So if you are interested in how we can help with your backup and replication needs, either to a private data center or to the cloud, please reach out to us. And we have several Scout Cloud partners that offer disaster recovery and backup as a service, a fully managed service to the cloud. So please contact us to find out how we can help. We can be reached at sales@inmarsh.com or the 1-800 number that's listed there. And we have a number of other solutions for Linux, AIX, and Solaris as well. So if you have some other environments that are not Windows and you want to see what we have,